In this video, we're going to apply the Pythagorean theorem to several different types of problems. The first section is just word problems. We're going to draw a picture and we're going to find our answer to the nearest tenth. So let's go ahead and read the first example. We have a 32-foot rope is attached to the top of a 15-foot pole. If the rope is stretched to the ground and fastened, how far from the base of the pole is it fastened? So we have a pole and we have a rope attached to it. This will be our rope. And the rope is 32 feet long. The pole is 15 feet tall. And the question is asking us, what's the distance from the base of the pole to where the rope is attached to the ground and fastened? So what we're going to do is we're going to write out the formula for the Pythagorean theorem. And again, the key is to identify the hypotenuse first. The hypotenuse is across from the right angle. When we're looking at buildings, or we're looking at poles, or we're looking at man-made objects, in geometry you're allowed to assume that this is a 90-degree angle because it's supposed to be built, that pole's supposed to be built at a 90-degree angle. Whatever is across from the 90-degree angle is C, also known as the hypotenuse, the longest side. So we have identified C, that's the most important part. And then the other two pieces, it doesn't matter which is labeled A and which is labeled B. So we're going to replace A with 15. We're going to replace B, well, with nothing because we don't know what it is yet. And we're going to replace C with 32. And then we're going to go ahead and multiply. 15 squared, we get 225. Let me use a calculator for 32 squared. We get 1,024. And then from here, what we're going to do is we're going to try to get B alone. So we're going to subtract 225 from each side. And we get B squared equals 799. And then from here, to get B alone, the inverse of squaring something is taking the square root. So we're going to take the square root of each side. So square root of 799 is 28.26, and it goes on. And we're going to round to the nearest tenth, so it's 28.3, and we want to put our units 28.3 feet. A good practice is to reread the question, make sure we answered the correct one. How far from the base of the pole is it fastened? And yes, we did. 28.3 feet is the distance there. Let's go ahead and look at number 2. Okay, the classic ladder problem. A 16-foot ladder is placed so that it reaches the top of a wall. The bottom of the ladder is 7 feet from the wall. How high is the wall? So we have a 16-foot ladder. And they tell us that the bottom of the ladder is 7 feet from the wall. So this distance right here is 7 feet. And they're asking us for the wall, what's the height of the wall? So again, we write out A squared plus B squared equals C squared. The most important part is labeling C, the hypotenuse. So C is 16. And then it doesn't matter, I'll label this as A and this piece as B. So A is 7, B we don't know, and then we solve. So 49 plus B squared equals 16 squared is 256. Then we subtract 49 from each side. And then I'm going to take the square root. And we get B equals 14.38. It goes on. And we round that to 14.4. And originally we were looking at feet, so it's 14.4 feet. We reread the question, how high is the wall? That is what we discovered. The wall is 14.4 feet tall. All right, number 3. The bases on a T-ball diamond are 40 feet apart. How long a throw is it from second base to home plate? So let's draw our baseball field, or our t-ball field. And they said that the bases are 40 feet apart. 40 feet. And we know that these are 90-degree angles. So basically what we can do is we can split this in half. And wait, let me see. How long a throw is it from second base to home plate? So, well, let's just call this home plate. And then we have first base, we have second base, we have third base, and they're asking us, you know, how far is it to throw from home plate to second base or from second base to home plate? So what we're going to do is we're going to label, first of all, C, because across from the 90-degree angle, it's the hypotenuse, the longest side. That's what we're trying to figure out. And then both A and B are 40 feet. We write out our formula, we fill it in. Oops, let me try that again. 40 squared, and then from here we multiply 40 times 40, we get 1600, plus 1600 equals c squared, so we have 3200 equals c squared, and then we take the square root of each side to get what c equals. And c is equal to 56.56, etc. So c equals 56.6, and this again was in feet. How long a throw is it from second base to home plate? That is what we answered by finding c. We move on to number 4. A square empty lot that is often used as a shortcut is 60 feet on a side. How much shorter is the diagonal across the lot than the walk along two of its sides? So we have our empty lot. It's 60 feet on each side. And we're looking at the diagonal. How much shorter is that? So we have, of course, if it's a square, we have a 90-degree angle in each of the corners. So I'm just going to highlight one of these triangles. We're trying to find C, because that's what's across from the 90-degree angle. We have A and B. So we go ahead and fill in our equation. And then square the 60, and then add up those totals, and then take the square root. And we get C equals 84.85, etc. And that's 84.9. Once again, it's in feet. Now, once again, we're going to read the question. This is the first time it's really going to benefit us to reread. It says, how much shorter is the diagonal across the lot than the walk along two of its side? So they weren't really asking for this amount, 84.9 feet. They were asking, how much shorter is the diagonal? How much shorter is the shortcut? Well, if you go the full distance from, let's say we go from M to T, I don't know. So point M to T, you take 60, you add 60 feet, and if you don't take the shortcut, it's 120 feet. And then if you do take the shortcut, it's 84.9 feet. So I'm going to take the 120, and I'm going to subtract the 84.85281,374, and we get 35.147. So when we round that, that's 35.1 feet. That's how much shorter the shortcut is. All right, next problem. A boat traveled 24 miles west. Let's make sure you know your directions. Okay, so about a boat traveled 24 miles west. 24 miles west. And then 14 miles to the south. And what's nice about directions is if you go, you know, directly west and you go directly south, you're going to form a 90-degree angle. And it says, how far is the boat from its original starting point? So the boat started out here, the boat ends up down here at the end, and we want to know that distance. So a squared plus b squared equals c squared. It's a right triangle, so we can use the Pythagorean theorem again. And we know that c is across from the right angle. So what we don't know is c. We know a and b, and it doesn't matter which is which. So this time I'm making a 24, I'm making b 14. 24 squared gives us 576. 14 squared, I think that's 196. Yep, 196. And then we add 196 and 576, and we get 772. Take the square root of each side, and we get c equals 27 point, and when you round it, it's 8, and this time the units are miles. How far is the boat from its starting point? We did find the correct value, and that was c, 27.8 miles. Now, these are not story problems, but as you can see, we have some challenging numbers to work with. So let's go through and just practice writing out the Pythagorean theorem formula and filling in the information and solving for our missing variable. So in this case, we have C, we have B, we're trying to find A. And again, this is the only one, like 16 has to be C. 12 could have been A, X could have been B, those are interchangeable. So we don't have the X value or A. We do have B, we do have C, and then X squared plus 144 equals, I forget what 16 squared is, 256. Subtract 144 from each side, and we get x squared equals 112. We take the square root of each side. Now here's where I want you to remember, and again it's to the nearest tenth. So it's 10.6. We round it to 10.6. It was 10.58, etc. I want you to remember that when you take the square root of something, the answer is really a positive or a negative value. In those story problems, we only use the positive value because they were lengths. Next problem, number 7. A squared plus b squared equals c squared. C is across from the right angle, so that would be the value we don't know this time. I'm going to label A as the square root of 11, B as 4. Remember, the square root and power of 2 are inverse operations, so when you square the square root of 11, you just get 11. 4 squared is 16, and then we add those together, and then take the square root. And we get x equals, and this rounds to 5.2, and we don't have the units listed here, so x equals 5.2. All right, let's look at number 8. I'm going to try to do this one a little bit faster. C is 34. We'll make b x squared, or b is x, and then 13 is a. So we have 169 plus x squared equals 34 squared, which is 1,156. Subtract 169 from each side, and then we take the square root. So x squared equals 31.416. X squared equals 987. Then you take the square root, skipping a step, and we get x equals 31. It rounds to 0.4, so 31.4. Number 9. a squared plus b squared equals c squared. And you know what? We're gonna run out of time on this video, so I'll finish this up in another video.